moving iron type instruments can be used as. Okay, we know that moving iron type of instruments and moving coil type of instruments are indicating type instruments. Okay, in this options, option C is correct. Now let us see option A. Okay, option A he has given as standard instruments for calibrating of other instruments. This is wrong because we use potentiometers for calibrating of other instruments. Okay, if you see in moving iron type instruments, theta is directly proportional to I square. It is having non-uniform scale. These type of instruments cannot be used as calibrating of other instruments. Okay, because this non-uniform scale is difficult to calibrate of other instruments. If you see out of these options, if option A is wrong, so option D is also wrong. Option C is indicating type instruments. Since moving coil is of indicating type instruments as on panels, generally we use it in laboratories for AC measurements. So option C is correct.
The circuit shown in the figure acts as. See, we can find the behavior of the particular circuit given in the figure by finding the truth table of the given circuit, that is A, B and Y. We know that this is the NPN transistor, means it turns on for logic 1 in case of a digital electronics. So if we take AB, means here two variables, means we will get the four combinations, that is so for 0 0 both the transistors are off, hence output is going to be 0. For 0 1, well, one of those transistors will be turned on, so output is going to be VCC, and in the 1 0 case also it is VCC, in 1 1 case also it is VCC. If we observe this truth table, we will find this circuit acts as a OR gate, hence option A is correct.
In this question, he has given a galvanometer of moving coil vibrating type having 30 turns. So N is equal to 30. Okay, and 4.5 mm into 25 mm mean area. So area is equal to 4.5 mm into 2.5 mm, which is equal to 11.25 into 10 power minus 6 meter square, and situated in a magnetic field of 0.8 Tesla. So flux density is given as 0.8 Webers per meter square, or you can write it as in Tesla. Okay, now what is displacement constant of a suspended coil? Displacement constant G is given as NBA. So 30 into 11.25 into 10 power minus 6 into 0.8, which is equal to 270 into 10 power 6 Newton meter per ampere. Option C is correct. He has given a transmission line. Rating of a transmission line is 132 kilovolts, that is voltage rating. Has a conductor weight as 680 kg per kilometers. Okay, length of span he has given as 260 meters and has ultimate stress of 3100 kg. We have to find sag of the conductor when safety factor is 2. Okay, now working tension, okay, T is equal to strength, that is ultimate stress by safety factor. Okay, what is ultimate stress he has given? 3100 kg. Okay, safety factor is 2. Now what is this one? 1550 kg. Okay, now what is sag? We know that sag is equal to WL square by 8 into T. This is the formula for sag of a conductor. Now what is W there? W he has given as, what is W there? W he has given as weight. Conductor weight he has given as 680 kg per kilometer. Okay, now what is this one? I can write this as 0.68. What is this? Kg per meter. Okay, into L square. Length of span he has given as 260. So this is 260 whole square. So meter square by, what is ultimate stress? That is working tension. Working tension he has given as, we found it as 1550 kg. Okay, now what is the final answer? We will get it is around 3.7 meters. Be careful with units because he has given conductor weight as 680 kg per kilometer and length of span as 260 meters. Okay, be careful about units, and answer is, you will get it as 3.7 meters, that is option D. In this question, we have to match list 1 with list 2. What is given in list 1 is the type of insulators we have. Okay, there are 5 types of insulators: pin insulators, suspension insulators, strain insulators, shackle insulators, and guy insulators. Okay, he has given 4 types of insulators here, and we have to match the application of these 4 type of insulations and how it is going to be connected in transmission line. Okay, we know that first type of insulators is pin insulators. Okay, the first type of insulators is pin insulators. Okay, pin insulators is used only for voltage up to 33 kilovolts. Okay, because beyond this 33 kilovolts, what is cost? Cost is directly proportional to X. Okay, that means cost is directly proportional to rating of that transmission line voltage. Okay, so what we do is we will not use pin insulators beyond 33 kilovolts, as cost is going to be the biggest factor in power system design. Okay, now what about next one? Next one is, let us take it as shackle insulators. If you see shackle insulators, it is connected only to low voltage distribution lines. Generally this is used for road and river crossings. Okay, so where this is matched with 1. Okay, if you remaining two are suspension and strain insulators. Suspension insulators, okay, how it is connected in transmission line? Suspension insulators, it is vertically connected. Okay, whereas strain insulators is horizontally connected. Okay, disc, suppose if you have disc like this, strain insulators are horizontally connected, and the word itself suggests you suspension insulators are connected in this manner. Okay, this is suspension and this one is strain. So what is the option? 2, 3, 4 and 1. So option C is correct. The values of ABCD constants for a short transmission line are respectively. Now what is short transmission line? Short transmission line consists of resistance and inductance. Capacitance is taken as negligibly 0. So this is R plus Jx, which is equal to Z. Now what is this parameters? Let us take this is sending end voltage and sending end current, and this one is receiving end voltage and receiving end current VR and IR respectively. Okay, since capacitance is negligible because it is only for less distances, well, less than 80 kilometers, which is comes under short transmission lines. Now what is ABCD parameters? Vs Is is equal to ABCD times of VR and IR. Okay, now write the equations here. Vs is equal to, I can write this as VR plus IR into Z. Similarly, Is is equal to IR for this short transmission line. Now compare with ABCD parameters, where A is equal to 1 and B is equal to Z, C is equal to 0 and D is equal to 1. So option is A. A is correct answer, since 1, Z, 0 and 1 are the short transmission line parameters.
Problem. We have to find the area covered by the curve y is equal to x square between the lines x is equals to 3 and y is equals to 0. The given curve is y is equal to x square and x is 3, whereas y is equals to 0. Now we know that y is equal to x square is a parabola symmetrical along positive y axis. So the parabola will be something like this. Now x is equal to 3 is a line parallel to y axis at a distance of 3 units. And y is equal to 0 is nothing but x axis. So we have to find this area. Now the value of x is varying from 0 to 3. So the limit will be 0 to 3. Area of the limit will be 0 to 3. And y dx, which is 0 to 3, y is nothing but x square dx, which can be written as x cubed by 3 between the interval 0 to 3, which is 27 by 3 minus 0, that is 9 square units. Option A.
Here the sequence x of n is given, we have to find the energy of the given sequence. That is, we know that energy of x of n is nothing but summation n minus infinite to infinite x of n x square of n. If we solve this summation, we will get the energy of x of n as 2 by pi, hence option A is correct.